Okay, so we just saw a note that tells us that we can evaluate things like displacement, distance, things like that. So here is what the note really is trying to say. Here's how we may use the note that says the integral from a to b of the derivative of f prime dx equals f of b minus f of a. If you just look at that, you can see that's a fundamental theorem, because what is capital F prime of x? It is the function, it is the derivative, it is a derivative of capital F. And what is it equal to? It's equal to the antiderivative of f evaluated at the upper limit minus the evaluation at the lower limit. Yes. Capital F on the right side is the antiderivative of the integrand, because the integrand is f prime of x. So just think about the definition of antiderivative. It's all there. That's the fundamental theorem. But let's see how we can do some different applications of this fundamental theorem. First of all, consider capital V of t being equal to the volume of like water in a reservoir at time t. Well, if that's the volume, V prime of t would be equal to the rate which the fluid flows in at time t. It would be the rate of change. Thus, the integral from the lower limit time t sub 1 to the upper limit t sub 2 of V prime of t dt would be equal to V of t2 minus V of t1. What is that? That's the change in the amount of fluid, the change in the amount of water present between the time from T1 to time T2. So you see, if you have this a volume problem, and then the integral of V prime is the change in the amount of fluid. Or another example would be bracket C of T being the function that equals the concentration of a product from a chemical reaction. The concentration of a product from a chemical reaction at time T. Then the derivative C dc dt is equal to the rate of that reaction. That's the rate of change with respect to time. Thus, the integral of the derivative of bracket C dt is equal to the concentration at time t2, the latter time, minus the concentration at time t sub 1. So what is this integral? It represents the change in concentration C from the beginning time t sub 1 to the ending time t sub 2. And you can think of other applications like that. Those are just two examples, and we're going to do some word problems like that.